we're looking at some problems in Cal 1 under integration, and we're going to be looking at the technique of U substitution, and we're going to start off with doing some indefinite integration. So know the difference between indefinite integration and definite integration. Definite integration, like in the previous videos where we have bounds, you'll see I don't think it was in the previous one, but back when we was doing some definite integration, you'll see a number here and then possibly a number up here, and that's definite. This is indefinite, and I think we worked some of these earlier in the story. But let's say that we had x plus 1 raised to the fourth power dx. Now you could, I just don't suggest this, multiply x plus 1 times x plus 1 and get out some polynomial, and then from the previous techniques of integration we could do this, but man, what happens if there was 100 up here? Alright, we couldn't do that. So what we're going to do here is we're going to use what's called U substitution, and we're going to let U equal x plus 1. Now we're going to have to take the derivative of this, and du over dx is equal to, so the derivative of x plus 1 is just 1. Now what we're going to do is actually the substitution. So the x plus 1 is going to get substituted, right, with the u, because u is equal to x plus 1, but remember it's raised to the fourth power, times in the dx, and what we're going to do here is we're going to solve for du. Just bringing this dx diagonally up, and so we have du is equal to 1 dx. Well, there it is, and so this becomes du. Now it's in a form that we know how to do the indefinite integral. So we add 1 to the exponent, putting the exponent down below, and then remember we have to say plus c here on the end. But we're not finished. What we got to do now is go back and substitute back in. So we have the x plus 1 raised to the fifth power, and it's all over 5 plus c. So that's what this guy would be equal to without just rewriting it up here. Now you can always check your work by taking the derivative of this, and let's just do that. So let's take the derivative of this, and so we end up with 5 x plus 1, right? Ooh, that's a 1 there. Take the 5, bring it out front, subtract 1. Of course, remember we still got this 5 down here in the denominator, and then we take the derivative of x plus 1, which is just 1, and the derivative of c, of course, is 0, but when we simplify all this down, we get x plus 1 raised to the fourth power, and that's what we started with, x plus 1 raised to the fourth power. So you can always check your work. So let's look at another one here. This would be slightly different. So we're going to have the integral of 1 minus 4x raised to the seventh power. We're going to throw in a negative 4 here. I know normally you wouldn't write it like this, but there's a reason why we're doing this. So we let u equal 1 minus 4x. Usually whatever's in parentheses is what we're going to let be our u. And we have du over dx is equal to, so we take the derivative of this guy, and we get negative 4. But we want to solve for the du. And there you go. So as you can see, we can do the substitution. That's going to get replaced, and this piece here is going to get replaced. And so we end up with the integral of u to the seventh times du, and then we can easily do this, and then plus c, and then go back and substitute back in.